Everyone's got these? Great. So a little introductions first. So I'm Brooke. I no longer work in Elixir, but I worked in it for about 3.5 years, give or take. I've written a couple libraries. The ones that I'm best known for are probably Exceptional and Witchcraft. Witchcraft ports over basically the Haskell standard library into Elixir, which has some interesting trade-offs because it's not a typed language. And Exceptional helps with doing happy path error handling or happy path coding. Done a couple keynotes, bunch of talks. 2 weeks ago I was in New York at MPEX, which is that photo, which was a lot of fun. I had a chest infection, could barely speak. I muddled through. I'm from Vancouver, where I founded a couple meetups, including the Vancouver Elixir and Erlang and the functional programming meetup out there, along with Roman, who's doing the Rock Solid Haskell workshop today. So a little bit of housekeeping, obviously, be awesome to each other. Safe space, zero judgment, no such thing as a stupid question. Point here today is to learn, so ask as many questions as possible. I don't have all of the answers, so if there's something that you ask and I don't know, I will make sure to look it up at a break. All of the code examples, obviously, strongly encourage people to type it in as we go along. There's a lot of value to following along, even if it's just typing in the terminal and playing around with stuff. If I'm giving a lot of exposition, see if you can break it. We'll also try as much as possible to pair off into exercise buddies, though it's 2, 4, 6 people. There might be enough of me to go around, so hopefully. Does anybody else have other ground rules they'd like for this session? Cool. So goals for today, mainly to give you a sense of what Elixir is, how to set up a project, generally to make it so that you can take this as a solid foundation to keep learning afterwards, right? So you should be able to get up and running after today, but you certainly won't know everything. We will not be covering Phoenix unless we end up blowing through a lot of material. Phoenix is the main web framework for Elixir. That's the draw for a lot of people coming in. And yeah, obviously we're doing a CLI chat app, so we're going to be talking a little bit about networking and processes. This is also really a cut-down version. There's a 4-day intro to Elixir and Phoenix that I give. This is the 6-hour version of the Elixir half of that. So again, if we do blow through stuff, we can find material, but the philosophy here really is to give sort of a focused, the basics that you'll really need. Less is more. Let's get a really solid understanding. And just entirely out of curiosity, because a lot of people who are interested in Elixir are Ruby refugees. Who's coming from Ruby specifically? Anyone else? Wow, that is the first time that's happened. Interesting.
I'm coming from Smalltalk, which is the original Ruby.
Yes, good point. Cool. So format, roughly 2 halves. Part 1, toolbox, interacting with the REPL, setting up projects. A little bit of OTP, the Open Telecom Platform, which is a bit of a misnomer. People talk about OTP as a set of the main core libraries. It's actually the entire platform, including the language and the VM and everything, but we're using here in the more colloquial sense. And then we're actually going to get some stuff done. We're going to build a chat app, have some more sophisticated exercises to walk through. And then, yeah, time permitting, we'll talk about supervision trees, structs, protocols, etc. Let's run the demo. Actually, I have to plug in a different router. I ran into this last year where the ports wouldn't forward on the university's Wi-Fi. no power. Do you know if there's a plug somewhere I can plug this into? No?
On the table here.
Oh, right, that would make sense. Okay. All right. Actually, might make it a little easier. Okay. So if you want to CD into the quick chat repo that you cloned, and you want to mix steps get as well. And you'll want to type in this. Oh. I get that backwards. I did get that backwards. All right. The -x mix should go at the end. All right. Oh yeah, it is just start. Okay. So you're going to want to import quick chat like so, and say start. And so in this case, it just says my local machine there, latte.local. I should be able to send, a message, hi, for example, right? So this isn't networked up yet. This is just sending messages out to anyone connected, which is only yourself at the moment. Okay, so we can do that. We can send a DM to myself, let's say, which is this. Right? Except I can't actually send it to myself, but you get the idea. I can look at my list of peers, and that's about it, right? So if I start this up with, so if we all want to get onto this Netgear, that is straight out of the box, so it doesn't have any restrictions whatsoever. It's Netgear 24. And just close this window when you get on there, and you're going to need to find your IP address on the network. No password. You just close that window.
It's asking for one to connect to the Netgear 24.
I might just have one. Really? Oh, indeed. Tiny Planet 450. And I'm going to have to reference some stuff on my phone here just because now I don't have access to the actual internet. So hold on. Just.
Quick note.
Mm-hmm.
Getting error --the chat room. I did chat room at localhost, and then that fixed it.
Oh, interesting. Okay, so you're going to need to do actually exactly that, chat room at, and then whatever your IP address is on the local network. So it's going to be a 192 dot, actually no, I want to, should be a 10 dot, but yeah, then 192 should work too. There we go. And somebody want to give me their IP address when you have one?
Mine's .4.
.4. And then, yeah, sorry, import quick chat and start. Okay.
Should I see something on mine?
Yeah, you should.
I did start. It shows chat room at my IP.
Mm-hmm.
But I don't see anything after that.
And you're 192.168.1.4?
Yep.
Oh, chart room, chat room. How about now?
Yep.
There we go. All right.
I'm .3.
Yep, that's me. And you said you were .5? Okay. Great. Sorry, didn't catch your name. .4. Could you do the same thing, but with somebody else in the room that I haven't connected to yet? So anybody else? Oh, you. Oh, great. Even better. So I'm compiling a list of everybody that I've sent a DM to and everybody that they've sent a DM to. And when somebody new joins the network, we all broadcast out to everybody else. So we're building up a little mesh network, right? Yeah. Does anybody else have numbers? So I have .6. Oh, Tiny Planet 450. All lowercase.
Like PhD or something like that. You're kind of like broadcasting everybody you know about.
Yeah, exactly. And then there's well, I'll walk through the exact, when we're going to build this at the end.
Oh, cool.
Yeah. And that should go out to everyone who I'm connected to, so those addresses. And if you just type MSG and then a string, that should hit everybody as well. Yeah. We're also distinguishing between accepting DMs versus broadcasts. DM is in purple and has a little, I don't see you, monkey. Smell the glove. Oh, all right, cool. So this is what we're going to end up building by the end of the session. That's the second half. If we end up getting through that, there's also a similar exercise where we build a little shootout game where you can point at people and fire, and we see who wins. All right. So you can disconnect from that Wi-Fi and get back on the main network. Display. And so that chat app that we just looked at is maybe about, without docs and everything, it's about 100, 150 lines. So we get a lot pretty quickly because it's really built for telecom, which is what we're going to be talking about next. A little brief history of Erlang and Elixir. So you may have heard that Elixir has a special relationship to Erlang, which is true. They run on the same virtual machine. Erlang has been around quite a bit longer. So it was introduced in 1986 by an entire research group at Ericsson. But the main authors are Mike Armstrong, Robert Verding, and Mike Williams. It's both a pun on it being Ericsson language, Erlang, and named after a mathematician, Agner Erlang. And they built it to run high-performance network switches for phone lines, right, in the mid-'80s. So they'd have these, big boxes, and it has to handle whatever, 500,000 concurrent phone calls. And if one of those calls drops, you can't drop everybody's call. You just drop that one. It kind of has this weird syntax, very inspired by Prolog. In fact, the first version was written in Prolog. Then they rewrote it in C just for speed. We have full interop in Elixir with everything in Erlang. You can call Erlang from Elixir and vice versa, and other languages on the Beam as well. The Beam's the VM. There's Alpaca as well, which is an ML. And they happened to land on functional programming and the actor model entirely by accident. So they knew that they were doing something kind of functional programming-ish. It's not pure FP, so it's not Haskell. The actor model, they thought that they had come up with this, kind of cool message passing system, and then they read it in a paper, 4 or 5 years later, like, oh, it implements the actor model. Like, oh, I guess it does. That's cool. Elixir is much, much newer. The first release, the beta, was 2011 from Jose Valim and some of his colleagues at Platforma Tech. They were a Rails shop in Brazil, and they were getting a little bit frustrated with the lack of concurrency and the performance of Ruby. So they started playing around with different things, had a little R&D project. Jose and a bunch of the other core contributors to Elixir were Rails core team members. So they've kind of, it's them trying to fix a lot of their frustrations from Rails. As I mentioned before, it runs on the Erlang VM. And we get all the nice concurrent, fault tolerant, etc. stuff that we get in Erlang in Elixir. It was originally just a DSL in Erlang. It was just macros. They've since rewritten it so that it doesn't have to go through Erlang. It compiles straight down to EVM bytecode. Philosophy of the language is pretty straightforward, right? We want something that's readable, friendly, something that people actually want to use, fault tolerant, lightweight, and modern. So Erlang, at the time of release, didn't have UTF-8 out of the box. You had to import it as a package. So they wanted, have a more batteries included language, encourage testing, documentation, type specs, all of that good stuff. Obviously, there's a pretty heavy Ruby influence on the way that the language looks and feels. Has a similar philosophy, very pragmatic. Obviously, a lot of the people working on Elixir, especially originally, were people coming from Rails. And then they brought in some of the superficial aesthetics. It has do blocks, dot syntax, and truthiness. So you can say if one, then this thing, and it'll work. A lot of companies are using, well, the Beam at least. So some of these are Elixir, most of these are Erlang right now. WhatsApp was, I'm told, like 5 Erlang hackers in a basement, and they got sold to Facebook for like $1 billion. They were able to do 2 million concurrent connections on a single node, which is pretty good. Amazon, Facebook, Motorola, Ericsson, Heroku, React is all written in Erlang, and there's even a board, like an actual piece of hardware that native language is Erlang. Right? It's used a lot for infrastructure, orchestration. A couple of weeks ago, I was talking to somebody from TD Bank. They're rewriting a large part of their infrastructure, and especially the orchestration layer in Elixir, right? So that they can get the fault tolerance and the automatic restarts and all of that. The famous quote from Joe Armstrong is, "If Java is write once, run anywhere, then Erlang is write once, run forever." They have systems that have been up and running for 20, 25 years. The big claim to fame is this one about halfway down, 9 nines of uptime, which is 32 milliseconds of total downtime per year, which is done through a number of techniques, including hot code reloading, which we're starting to see a little bit more. With things like Docker, you can do some of these things, but they're one of the originals that did this. Now, should you expect 9 nines of uptime out of your application? I would say no. This is team working in telecom. It's still much easier to do a rolling deploy, like much easier. It's there's a fair bit of complexity that goes with that, but it's possible. It's not, this high availability doesn't mean that there's no errors. It means that if there is an error, your service is still up and available. You may have dropped that one call, but the other 500,000 phone calls going through this system are still working. Right? Or in a more more common context, you have a socket server. You haven't dropped every text message or music stream. You've just dropped one, and that one will automatically restart. Right? It's aimed at soft real-time, so you should be able to do, socket servers, the most common use case that I see. People do a hybrid approach where they'll, instead of adding, what do they call it now in Ruby, active, they have like a socket thing in Rails now. It's not totally performant, and it's definitely not, doesn't hit the, that real-time guarantee. So people will write a socket server in Elixir, push messages out to it over RabbitMQ or similar service, and then have it handle all of the sockets. Fault tolerance is probably the big selling point. It's not unique to Elixir, but it's probably the easiest one to get up and running with. Very easy to do distributed computing and clustering as well, because it has this networking focus. So let's look at some of the basics. Go into your terminal and type in IEX. This is Interactive Elixir. So these slides are about a year old now. So this is why they say 1.4.2, but you should see 1.6. something. And when that loads up, that loaded for everyone? Yes? Excellent. All right. When that loads up, you'll see Erlang/OTP, I guess 20 or 21 now. The architecture of your system, threads, and then this hype word, which means that it's using this high performance backend that's relatively new, a couple years, for the Beam. And you have dtrace running in there as well. We also get a handy little prompt. So you go in and type 1 + 1, you should see 2. And we can do a little bit of string concatenation as well with these little diamond operators. Another handy trick for doing, you can use string interpolation. So inside of double quotes, if you put a hash and then curly braces, you can output variables in there. There's also a break menu. So how do you get out? If you type exit, nothing happens, right? So you, on most systems, it's Control-C to get out. But that doesn't get you completely out of the system. That just gets you to this break menu. And you get some options. So go ahead and hit Control-C. So A is the way to get out. That's abort. So don't do that just yet. C is continue. It can be a little bit confusing because it doesn't draw another prompt for you. It's just blank space and you can continue typing. It's done that way because you might be in the middle of typing something and you accidentally hit Control-C. You can just keep going, multi-line. Right? I for info will tell you about your system. Process info will tell you about this process, like the IEX process on the system. L tells you the loaded modules that you have access to, which by default I believe is only kernel. K for kill. It's to kill a particular process. So if you have something that's misbehaving, you can have it ended, and if it's in a supervision tree, it may get restarted. It comes automatically with a database, or actually technically two databases, in-memory store and a persistent store. The in-memory store, ETS, Erlang term store, gets used a fair bit. It's pretty high performance, in-memory store, and is shared across all of the processes. D is for distribution, tells you about the specific build that you have, and V is the version of the compiler you have. So you can go ahead and hit that A to abort out and hit enter.
Is there a way to clear that terminal? Clear that?
I mean, I've never actually tried, other than Command K. Try clear, maybe.
Oh yeah.
Yeah. Okay. Cool. So let's talk about syntax. So true primitives. So why true? Everything in Elixir, or everything on the beam, is serializable. So they end up using a lot of sugar to fake certain constructs, right? Which has the nice, added bonus that everything is very JSON serializable because it has to already be able to serialize stuff down to go over a wire. The reason they do this is because it's designed for networking, right? So it has its own binary format that it can send stuff, very efficiently over the network. It just opens a little TCP server, which is what it was doing before. Nothing in my code specifies open a TCP server at this socket, right? It just knows, okay, I'm talking to another machine running the beam. Send it over in this format, and it can start processing it, stream processing, automatically starting to do pattern matching, all of that. So we have, obviously, integers, positive, negative integers, floats. They're not considered different types. They will get cast to whichever one is, more specific. So you can do 2 plus 8.1, and it'll work. We also have these weird ones with this colon in front of it. It's like :A. These are sometimes in other languages called symbols. They're called atoms on the beam. And they're basically immutable strings or some arbitrary identifier. They're kept underneath just as an integer in a special table, and then just a mapping to that integer. As I said before, so a lot of other things are sugared on top of this. So if you need spaces, you can just stick it in quotes and then put a colon in front of that. That is also an atom. Modules are also atoms. They just have the sugar of having a capital at the beginning. And so is nil, true, and false. So true is an atom, and it's the same thing as :true. So if you do :true equals true, it is that. Same with nil. The gotcha here is if you're checking, if you need to do some type checking at runtime, and you say, well, if it's an atom, I want it to behave this way, and if it's a Boolean, I want it to do that. These are Booleans, but they're also atoms. We have some container types. This is a byte string, so just like a regular string, and they get the double quotes as sugar. So these two are completely equivalent, right? A is 97, B is 98, etc., which means that we can do stream processing and pattern match on them. With a single quote, it's a linked list. When you're interacting with Erlang, they don't have out-of-the-box byte strings. It's a separate module. So you'll end up working a lot more with the list representation. But if you're staying inside of Elixir, it's recommended that you stick with the byte strings. We also have tuples, which get the curly braces. They can be empty or have an arbitrary number of elements, but once it has that number of elements, it is fixed. We'll talk a little bit about the difference between them and lists in a little bit. And if you want key value pairs, you put a little % sign in front, and that gets you a map. The sugar version here is with, these are actually atoms. We just flipped the colon to the other side to make it read a little bit nicer. You can also use any other, you could use numbers, etc., as keys. Here we have a string. You just have to give it with a fat arrow. And then this bottom one, probably looks pretty familiar, is a anonymous function, right? It can have an arbitrary number of arguments as well. This is just with one. Everyone following so far? Awesome. There's also this one, which you'll see, and this is pure sugar. It looks a lot like a map, but it has the square braces. It's actually this underneath. So if you want to pattern match on it, you break it out into the tuple. So what it really ends up being practically is it's a map, but each element is at a particular position. So it's a little bit more efficient because you don't have to, the VM doesn't have to look up where it exists in that thing. I want this thing at the first position or the second position or the third position. And we end up using this a lot for like passing around options and params and that sort of thing. Does anybody have an idea on why we want modules to be atoms in particular? Fast lookup is one, yeah. Any others? So fast lookup, they can't conflict because there can only be one with that same name. And we end up doing, well, it depends on what you're doing, but if you're writing a library, you end up doing a lot of dynamic programming. And you can create an atom out of a string, make that into a module name, it'll work, right? And so you can create things on the fly very easily, which is nice. And then, in addition, Erlang uses atoms for their module names with lowercase, so you get the interop. So it's, we feel very, used to seeing, this capitalized version. So you can see mymodule.foo and expect that to be a function. If you're interoping with Erlang, you could have : lowercase mymodule.foo, and that'll still work. It's still a module, right? Open up a text editor, create a file called foo.ex. It doesn't have to be foo, it could be anything. Just to say it doesn't have to be the same as the module. And type this in. Def module is how you, define a module. And this is a pattern you'll see all over the place, is def something, and then this do block. So we're defining a function echo, and we're just going to have it io.inspect, which means take whatever kind of thing this is, turn it into a string, and print it out to the console. You also may notice that there's two different versions of do here. Right? I have do end and comma do colon, and those are equivalent. Right? The only difference here is that this do end can handle multiple lines. But we could have written echo A as do, put this on the next line, and then an end. Right? But since it's just a simple one-liner, this ends up being better. Then if you go into IEX, you can C for compile, foo.ex, or whatever the path is to that file that you created. And once you have this foo, type foo.echo space and then whatever you'd like, or you could put it in parens. Up to you. And what do you get? How many times did you see it in the console? Twice. Why? Any ideas? Yeah, exactly. So you will always have a return value. Always. There's no way to escape with nothing. Right? So let's say we wanted to make a change to the foo module, right? So instead of echo A, we're going to have io_inspect nil instead. How would we recompile this without having to exit out of the console and get back in? Any thoughts? You just do this again. It'll just recompile it. You'll get a warning that it's overriding an existing module, but it'll be totally okay with it. This is one of my favorite things in Elixir. The help function. So it's just h, and you can just say h module, and you'll get the docs for it. So type h, and anytime we have these parentheses, you can just put a space. It'll assume that it's the parens. They're considered a best practice, but if you're just toying around in the REPL, it's totally fine to just do a space. Do h space and then enum with a capital E. And you'll get the docs for enum. The module level docs, sorry. We can also do, again, h, let's do enum dot reduce. And you'll get the docs for the reduce function in enum. And then you can also do it with this /arity, which we'll talk about a little bit more later. But there's two versions of reduce. There's a version with 2 arguments and a version with 3 arguments. So you can say enum.reduce/3 to get that specific version. This is really, really handy if you're coding on a plane and you want to look up docs really quickly. If you don't want to have to load up the browser and go hunting around. If you do want to go looking at the pretty version of the docs, they basically all look like this. There's a nice xdoc package for generating these. This lives at hexdocs.pm/elixir, and that's anything in the package manager in hex. That has documentation will be at hexdocs.pm/ whatever the name of the library is. This just, standard libraries at Elixir. It has some kind of neat features that I like. So other than looking pretty, We have pages, which is like, readmes, explanations, modules, which is what we're on now, a list of modules. When you click into one of those, you can expand this out, get a list of all the functions in there, including their arities, exceptions for exception structs, which we're actually not going to cover today, probably. And then this handy little search box at the top. So if you go in there and you type in map, for example, you will get a list of every module that has map in it and every function named map in this package, in the standard lib, which is pretty handy. Tuples versus lists. I promised we'd look at these a little closer. So tuples are the data structure of choice on the beam. They're more like arrays in most other languages, right? They're contiguous in memory. It's really a pointer, a set of pointers of a fixed length pointing out to other data. You have random access, so accessing the first element or the last element takes the same amount of time. And constant time access or update. Downside is if you want to change the length, so I want to go from 4 and I want to add another element to the end, make it 5, we're going to burn this one to the ground and create a new one. Okay. Or rather, this one may hang out in memory for a bit until there's no references to it. It's going to, because the VM counts the number of references. So especially if you have a very long array, it can get quite expensive to do that, or if you're doing a lot of updates to the length. Right? And oh yeah, the other thing is they don't have to all be the same type, right? They're heterogeneous lists and tuples. For lists, the only thing that we've changed is we've made these into square brackets. This is of an unfixed size. It's just a linked list. It's a recursive data structure, so it makes it very easy to do inductive solutions on, which we'll look at in a bit. In fact, that's just sugar for this. These are the same. Right? So it is a list wrapped with a list with one element, wrapped in a list with one element, wrapped in a list with, and so on. Pushing things into the first element, new things into the first element are essentially free. Right? Accessing something deep into the structure is going to take linear time. So if you're going to look at something 100 elements in, you have to follow 100 links to get in. Okay. So using some of the stuff that we've just learned about, using your hex docs especially, how would you take a list and change all of the elements in it into strings? And as a hint, you'll want to use that hex doc that we were looking at before. And one other little hint, we were using io.inspect before. io.inspect also prints. There's one called inspect that does it without the printing.